Welcome to Data Skeptic Machine Intelligence, our podcast series exploring contemporary topics in artificial general intelligence and large language models. Today on the show, we're going to talk about one of my favorite websites. It's arXiv.org, arxiv.org. As will be somewhat obvious to people who read our show notes, I would say 90%, probably maybe 95% of guests are people who've previously published on the arXiv, and we're going to talk about a paper they published there. We actually crawl the arXiv over here at Data Skeptic HQ. We compute BERT vectors of the titles and abstracts, and that's the main input to the pipeline we use for finding guests on the show. Much like our guest today, who also did some research on the arXiv. In this case, a deep dive into questions related to large language models and how they're affecting research. Safe to assume there's an increase in publications on this topic, but how much? Who's publishing and what kind of crossovers exist? All that and more coming right up.
My name is Rajiv Movva. I also go by Raj mostly. I am a PhD student in computer science at Cornell Tech. Cornell University has a basically tech-oriented campus for graduate students in New York City. So I'm lucky to be in New York City. I'm specifically, still figuring things out to some extent, but have been interested in NLP for the last few years and more specifically sort of the social implications of machine learning and NLP systems, NLP, natural language processing. There's a lot of work to develop new models, but how will these models actually impact society-adjacent society-facing applications, for example, health, law, or these sort of adjacent to real-world applications. I'm more interested in that than sort of like doing very core sort of methodological research. I'm more interested in thinking about what are the impacts of models and how do we make sure they're more likely to do good than bad.
Well, it's either an incredibly exciting or incredibly terrifying time to be studying NLP, maybe a little bit of both. What's it like being knee-deep in that research as the field evolves quickly?
Yeah, so I would say that I'm to some extent an outsider to NLP. In this paper, for example, we sort of, have some foot in what's going on with NLP, but we're also trying to sort of study it from an outside perspective and see what's changing about NLP. So that's a question about how are things evolving and what's changing and what's it like is exactly what we tried to get at. Sort of my on the grounds perspective is, again, as someone who does do a little bit of NLP, but also is interested in sort of social implications. I think, that field is also moving very rapidly, figuring out how to steer these models in a good direction, also figuring out sort of what are we actually even concerned about? Like, are we more concerned about short-term harms or long-term risks is another thing to think about. Overall, I feel like there is a lot that's going on. It's very hard to keep up with, and that can sometimes be overwhelming. But I also think it's interesting and exciting.
I think it's fair to say we're in the early days of large language models being used in society in different products or in decision-making processes. Do you feel that that's kicked off, or are we about to see a wave of these sorts of implications?
Yeah, like you're saying, we're still in early stages. There are some applications, like, for example, if you're a software engineer, I think a lot of software engineers nowadays, actually use sort of code generation assistants, and most notably GitHub's Copilot. I use Copilot. That's probably the primary way I interact with language models on a daily basis is Copilot. So there are some niches where, there already have pretty high adoption, working them into customer service or other sort of very tangible products, will probably impact a much larger fraction of the population. And, we haven't seen as much of that yet, but we're probably going to be looking at a lot more AI generated text, in the next few years.
Well, I know in the paper and the research you've been doing, you're able to get a sense of publication patterns, how people are at least writing about their research using large language models. How do you come by something like that? What's an underlying data set that can help answer questions?
So we use the arXiv. So that's a website where it's not peer reviewed. It's a preprint server where a lot of researchers, especially in computer science, post their work. arXiv originally had high adoption in the 2000s among other communities like physics. But yeah, in the last 10 years, I think most computer science research gets published in conferences eventually, but also gets posted to arXiv. So that was a pretty good data source because it's all freely accessible. There's very sort of new work that gets posted to arXiv because, like I was saying, it's a preprint server before people actually get their work peer reviewed. So there's a lot of stuff there. it's a great way to sort of capture like an on the grounds look at things that are happening, now. Like every day there are many new LLM related submissions to the archive. There are some things that are missed, I think, from archive, but also like looking at papers more broadly, like some companies don't really publish their work as much. And so we wouldn't be able to see, their internal research, obviously. But I think, to get some summary of what's going on, archive is a very good place to start. And that's what we used.
And is there any metric you have in mind by which you can scope the size of this? How big is the data?
It really comes down to how you slice it to get a specific number. But so what we looked at, we started with everything that was posted to archive within a computer science subcategory within the last 5 years since 2018, which I think everyone would agree that models before 2018 were probably not really large language models. So we started the sample in 2018, took everything that had been submitted to archive in a computer science category, so that's 400,000 papers, and then we asked, of those 400,000 papers, how many of them have sort of any keyword in their title or abstract, which is related to language models. And that's sort of how we defined a set of papers to analyze. And that turned up 17,000 papers. So that's quite a bit. And, not every single paper in that set would, have unanimous agreement that it's a large language model paper. But it gives some sense of like the scale of how much research there is in this space is like, on the order of 10,000 papers.
Well, just out of curiosity, you went with a keyword search. I consider that kind of an old school technique. You could also have just submitted each of those abstracts to a large language model and asked it, do you find this abstract to be about a large language model? Was there any, kind of design choices or things like that you had to make along the way?
Yeah, totally. That would definitely be a possibility. Yeah, I think with the keyword search, within this field of like science of science is the term, to science of science being like you're doing science on the enterprise of science as a whole. So that I would say that's, the broader subfield which this work could be contextualized within. And I think within that space, it's important to do your work in sort of an interpretable and in a way that's easily reproducible and has sort of a clear understanding of what was done. And so I think a keyword search like made sense in that broader context of like science of science. And then also I think, start with a very broad set. I think if you like ask an LLM, is this paper LLM related? That might give you good accuracy, but like we actually weren't too concerned about false positives with this keyword search. And if you have a sufficiently broad set of keywords, you're probably going to capture most things which could plausibly fall into LLM related. So yeah, the reason why we wanted a very broad set was because we wanted to analyze sort of changes and see how this research space has evolved. In the last few years, we felt that like having some papers which were not totally LLM related, like that would sort of naturally fall out of our analysis. Overall, we wanted to prioritize like recall over making sure every single last paper in the set was like definitely LLM related.
Well, I think it's a safe bet to assume it's monotonically increasing in volume, but do you have any high level observations about the trends in publication?
Yeah, so when we first started the work, we just wanted to look at, how fast is this field exploding? And so yeah, I think we have a supplementary figure which mentioned this. And basically it seems like over 10% of all computer science research seems to be somehow LLM related nowadays. Basically, several factors higher than it was a few years ago even. So clearly a lot has changed just in this last year. Yeah, so we started there by just looking at the quantity of papers, but we actually realized that, everyone kind of knows that things are increasing quickly. So most of our analysis actually focused not just on quantity of the increase, but more trying to describe how things have changed, who has been responsible for the increase, what institutions are the biggest players, et cetera.
What are some of the broad other secondary analysis you want to do? The high level count's important, but as you were mentioning, who is publishing more? Could you perhaps just outline some of the overall slicing and dicing you set out to do?
I think the most surprising thing for us was the extent to which, this rise in LLM research centered around applications and societal impacts. So previously, natural language processing researchers were more concerned with sort of specific tasks within NLP. So for example, people would care about question answering. So if you ask Siri a question about like a fact, can it pull up the relevant Wikipedia article and serve you an answer and will it get it right? So sort of very narrow tasks like that. And now people are using LLMs obviously for sort of all sorts of things, from sort of code generation to healthcare and sort of health information and, solving medical challenge problems or analyzing legal documents, recommender systems, just really all sorts of things. And for example, we saw that So papers on arXiv can designate a category within computer science that they're related to. So we found that the category within arXiv that was actually rising the fastest by far was the subcategory of computers and society, which is sort of deals with all sorts of societal implications of technology. And that was the one which had the greatest rise in LLM research. So I think that was very surprising, sort of topically, how much the quantitative data confirmed our intuition that LLMs really are having quite a big impact on society and will continue to. Another application that I should have mentioned earlier, which I think is maybe one of the biggest ones, is education. So not just, how are LLMs going to be useful in education, but there are all sorts of people writing about, will LLMs actually be net beneficial or harmful in education? How do we rethink examinations or application processes, for example, in light of the fact that LLMs are so performant nowadays? So all sorts of this stuff was very interesting to see pop out in the data. So yeah, that's one sort of a topic-based analysis. Another analysis is an author-based analysis. For example, what affiliations are rising the most and what affiliations are accounting for the most LLM research. And it's important to note that, this affiliation analysis, for example, this is about the research landscape. It may not necessarily reflect, the fact that everyone uses ChatGPT, and that's from OpenAI. But OpenAI doesn't publish that much, which is one thing we found in our work, and I think people kind of broadly know. We actually found that, so Microsoft and Google are the top two industry producers of LLM research just by the count of the number of papers they've written about LLMs. And then after Microsoft and Google and a few other large industry players, actually the long tail and the vast majority of work is actually from universities and academic institutions. A lot of expected ones like CMU, Stanford, a lot of top Chinese universities too, like Tsinghua. A ton of academic players that are having a huge impact in the research landscape, even though we may not hear as much about their work as we do about Google and OpenAI and Meta and stuff, sort of in the public discourse.
Well, Google and OpenAI are certainly pouring lots of money and lots of talent into these areas. When you look more to the academic institutions, does it require the same sort of, I don't know, firepower is the right word? Is it large institutions that are publishing a lot, or is there room for smaller groups as well?
So we actually saw that if you look at academic institutions versus industry institutions, the total percentage of papers is actually higher in academia this year compared to before this year, which may seem counterintuitive because you would think that as these models are getting bigger and bigger, sort of you need more and more compute to actually use them. Compute is generally centered in these very rich, well-funded, profitable industry institutions, as you're pointing out. So how are academics actually publishing a larger fraction of these papers? The main difference between academic work and industry work is that Google, Microsoft, Meta, OpenAI, they sort of have the firepower to train their own models and fine tune their own models and do all sorts of things in the training process. Less of that work, that sort of methods training work, is happening in academia, and more academics seem to be using sort of API access of models. So a lot of academics use the OpenAI API to access GPT-4, or maybe we'll use like a small version of Llama, etc. So they're using either open source models or sort of API access of models to study them or apply them to societal applications instead of sort of training their own models, because like you're saying, most of that can't really happen in academia. So I view this as, interesting, and also researchers from academia like us are able to actually study the models that are being widely used, and people can audit these models, for example, audit them for bias and harms to get a better understanding of, are they going to be beneficial or harmful. That said, I think it's, you can only do so much if you don't actually have the underlying weights of the model. So no one has GPT-4's weights or even knows how many parameters run into GPT-4, and that limits the number of things you can study about it. That is a rift between industry and academia that will only probably continue to grow as details about the models become secretive and they get bigger, et cetera. And so we study collaboration between different institutions in our data set. We wanted to see, are there some types of institutions that are collaborating a lot? And also, more interestingly, is there notable the lack of collaboration between some types of institutions? Because insofar as there's, a notable lack of collaboration, there might be competition, and competition could have other downstream impacts. We define a collaboration as a paper which is written by more than one institution. So, for example, Microsoft or Google write a lot of papers with universities like Stanford, CMU, etc. So there are a lot of industry academia collaborations, which kind of makes sense. A lot of PhD students intern at companies over the summer, for example, and they write papers together. But we saw, a very notable dearth of collaboration between industry institutions. Microsoft and Google almost never collaborate. Pairs of industry institutions very, very rarely collaborate. And this isn't crazy surprising. Companies care about protecting their IP, et cetera. But it is interesting to see that trend confirmed in the data, and also potentially concerning because we've already sort of seen what happens when that's the case. So, for example, after ChatGPT came out, we saw Google and Microsoft, rush to release their own kind of chat style models in Bard and Bing Chat, respectively. These models weren't as performant and clean to use as ChatGPT, and more importantly, they maybe had like actual ethical concerns and led people to do things which were unsafe. That may have been the result of this pressure for these companies to put out models earlier than they actually should have been released, as a result of competition. So that's one thing we've already seen. And we also saw, maybe also not too surprising, but we also saw a lack of collaboration between US and Chinese institutions. So US and China, both industry and universities put out the most LLM papers and the largest models, but they very rarely collaborate in our data as well. And we think this trend holds in general. There could also be important sort of concerning implications of that lack of collaboration. Obviously, our paper doesn't speculate as to what those impacts would actually be, but yeah, competition could pose harms.
Well, as it stands today, do you see any major differences between the types of topics that industry is looking at and publishing about versus what academia publishes about?
Yeah, we definitely see differences. So I alluded to them a little bit, but yeah, to go into more detail on them. So industry is seems to be doing more sort of methods work around training. So for example, a lot of work in industry is around like efficiency and performance. There are techniques like pruning, which is removing some of the weights of the model, which you can do without really impacting performance. There's a technique called quantization, where you use a lower bit representation of weights in order to save memory for the model. There's a very big technique called knowledge distillation, where you can benefit from the accuracy of a large model and actually use it to make a small model better. So industry is working on all sorts of these sort of efficiency-oriented contributions to make models more deployable and usable for their products because, they care about the cost of deploying a model. And as well as these sort of more traditional core NLP tasks, potentially like search and retrieving information and answering questions. That's where we see more of an industry role. And then in contrast, academics work a lot on like applications. So healthcare is a big one. There's a growing emphasis on using language models for legal document processing and legal analysis. I don't have, great understanding of exactly what's going on in this space, but we see that, legal related work is popping out a lot in the data. That's some sense of the differences between industry and academic work.
You'd mentioned one area I'd love to zoom in on a little bit, and that's LLMs in education. I personally am very optimistic about the way these can be additive to a student's experience and help them learn faster and more efficiently and things like that. But even though I have that expectation, it should be science that tells me if I'm right or not. Yet we've had these for such a short period of time. I'm not convinced we have enough like longitudinal data to answer any questions. Do you have a sense of what the research gets into and what we can say at this point in time about LLMs in education?
Honestly, it's not my area of expertise either. I did see some of these papers pop out in our data as education being one of the fastest growing topics people are writing about. But yeah, I think people make arguments for both benefits and harms. I don't have a great sense of what the consensus is or if there is any, and I think you're right that we're going to need to wait to see how it shakes out. I mean, one thing that I've thought about a little bit and don't really have a great answer to is like how LLMs or writing aids might change like college applications, because application essays have historically been such a big part of how a lot of universities in the US at least make their decisions. And if you ask ChatGPT to write like an essay which describes a pretty personal aspect of your life, elaborate on it in a personal statement length essay, like I feel like it does a pretty good job. I don't know. I'm concerned to some extent, or just kind of curious about how college applications will shake out. I don't know if you've read anything on that.
I haven't, but I agree with you. I think it's a point of inflection in how that's all going to work.
Yeah.
So, similar question when it comes into societal impacts. I think it's in many ways too soon to say what some of them are. I'm sure there's good room for speculation by thought leaders, but do you find that we're living in an empirical world when it comes to those sorts of analyses?
Yeah, I mean, I do think that a lot of the work so far, like in education, for example, or law, a lot of it is more in the kind of trying to guess regime, or like listing some opportunities and challenges. You're right that we'll need like sort of more time before empirical things can actually happen. I think with some domains, like again, I keep going back to code generation because I feel like it's one where LLMs are really already having impact. So in that regime, for example, there's this one interesting human computer interaction paper that compares like software engineers' ability to solve coding tasks, like real world examples of things they might do in their job with and without an LLM assistant or a copilot specifically. And they find that for some tasks, there's actually a solid benefit in the amount of time it takes to complete it. So yeah, there are some domains where some empirical work has happened, but overall, we're going to need a bit more time before we get a clear sense of what the quantitative possibilities are here.
And I'm wondering if you could share a few details on, I guess, the engineering challenges in a project like this. I'm sure it's not trivial to manage this much data and do some analysis. What was the work like?
One of the challenges here was we have 17,000 papers and we want to organize them in such a way that we can make observations and trends that are digestible. And the sort of core of that was assigning papers into clusters and then labeling those clusters with topic names. Both of those steps are not trivial. There's a lot of work on clustering, data points in general in machine learning and data science. So we were able to use a lot of tools available for that. But even like, how do you convert a paper into like a mathematical representation is difficult. And so we used, another sort of advance from NLP, we use embedding models, which basically can take in any arbitrary string of text, usually up to some limit of words, and map that to a mathematical vector representation. So we did that for the paper abstracts only. And obviously abstracts don't tell you the whole story of what a paper is about, but they give you some solid sense. So we took each paper, got a representation of its abstract, and then clustered it using standard methods. And then now you have a bunch of like clusters, but what are those clusters actually about? And how do you label them succinctly? That's another hard problem. And we actually, funnily enough, used GPT-4 to help with the labeling. So we took these clusters, each one had about 500 to 1,000 papers. We took a sample of like 25 of them, threw their titles and abstracts into GPT-4 and said, what's like a succinct cluster name for this set of papers? GPT-4 unfortunately didn't do, that great, but it gave sort of a candidate start. And then, it was a lot of manual work to actually go through and ask, is this reasonable? Do I need to like refine this? And most of them I needed to refine. But yeah, so sort of that work of like actually taking 17,000 papers and designating them into a more digestible number of topics. So we ended up choosing 40 topics. That was one of the more tedious tasks of this project. But then once we had those topics, a lot of the analysis was easier to do because then we could go and say, okay, I know this paper is by an industry author. I know these other papers by academic authors. How do these two populations, industry and academic authors, differ in their topic count, for example?
And do you have any thoughts on maybe where this goes next? You have some really novel conclusions and results, but it seems like a endless opportunity to go deeper into the arXiv data and get other insights. If you had infinite time, what would be some of your pursuits?
Yeah, I think sort of a sub question with all of this changes and advancements in AI is like sort of what will the impacts be? That's been something we've talked about. There are two different camps kind of that would tell you different things, and also people study the implications differently. So yeah, I guess specifically, I'm interested in this question about these two communities, the AI ethics community and the AI safety community, which, if you're not sort of well versed with this space, those may seem to sound pretty similar, ethics and safety. But within this community, those two words actually mean something pretty different. So AI ethics tends to focus more on near term harms, things like algorithmic bias. So will a language model generate text which is biased against certain groups? Will it, stereotype minorities, for example, in its outputs? So those sorts of questions are generally more concerned with the AI ethics community, and then the AI safety community has been in the popular press and news a lot recently, and they're more concerned about long-term like harms and existential risks potentially from AI. So insofar as AGI is a possibility, should we be concerned about AI and destroying humans? And if so, what can we do to prevent that? So these both seem like very important problems, but these two fields don't overlap that much in terms of research communities. And it'd be interesting to get more sense as to why that is and sort of assess first, concretely, what are the different problems these two communities work on, and why do they, value these problems over the other communities' problems? So why is it that some people think that sort of near-term harms are more critical to focus on, and why is it that the safety community, for example, thinks that existential risk from AI is a real concern that many more people should be working on? We could make some headway on this question from the data we already have of papers, because I think some of this conversation happens in the research space. We would have to look further than just papers and look at other forms of documentation and other statements and petitions and all sorts of stuff to get a better understanding of really the divergence between these two communities.
Well, if you had told me that 10 years ago, I might say, well, the Chinese language is so fundamentally different. The statistical models they're going to have, the structure of grammar, everything is, they're going to need totally different algorithms and tools. Is that still fair today?
Yeah, that's a good point. Just the underlying fact that English and Chinese are very different is probably relevant here. There are a lot of NLP papers coming out of China that are being published in top venues that focus on English as the language. So I don't think the language difference explains the whole story. I think there is potential for collaboration in that people are working on similar things in both the US and China, but there's still competition due to other reasons, like more socio-technical reasons.
And I'm curious, what's next for you in your research?
Yeah, so I'm still relatively early on in my PhD, and I'm very much still figuring out my research interests. I find that this style of work of, trying to analyze science from sort of a higher view, like a sort of meta studies of science, I find this to be interesting. And I think it reveals a lot of things which people take for granted and may not think about as much as they should be thinking about. So I like this style of work. That said, I also have interest in actually using language models, improving societal outcomes. So I'm interested in the potential for large language models in health applications, specifically applications that might improve health equity. So people write a lot about how LLMs can be harmful for equity and bias and fairness. But I think there's a lot of room for these models to democratize access to healthcare, for example, which is traditionally very siloed, and there's a huge power imbalance between doctor and patient. And I think LLMs have the potential to increase access to information in a way that could actually improve equity. So that's something I would maybe like to explore more in a more experimental setting. Yeah, I'm also interested in sort of the core methods behind these models to some extent. For example, the reinforcement learning for human feedback space is very interesting and underexplored in some ways. And so I have some ideas there too. But generally, just trying to figure things out in this very rapidly changing space.
Well, lots of good directions and opportunities for sure. And is there anywhere listeners can follow you online?
Yeah, I'm on Twitter. Maybe my handle can be posted in the description, but yeah, it should be easy to find.
Yeah, we'll have a link in the show notes for people to follow up. Raj, thank you so much for taking the time to come on and share your work.
Yeah, thanks so much, Kyle. It's really nice to be on the podcast.